Hey guys, welcome to my channel. I'm LeetCoder. If you guys are new here, I pretty much do LeetCode style questions and I explain things in the simplest way possible. Today we have an amazing problem, something I'm very excited about. So let's quickly get into it, guys, and see what's going on, right? So the problem's called find duplicate subtrees, right? So this is a very good title. I like it. It says given the root of a binary tree, right, return all duplicate subtrees. It says for each count of duplicate subtrees, you only need to return the root node of any one of them, right? So it says two trees are duplicate if they have the same structure with the same node value, right? So this is a very good thing that they're telling us, guys, right? Okay, so they're pretty much asking us to find duplicate subtrees, right? So we find them and then return the root node of those subtrees, right? So they return the root node of the subtrees, or I'm saying they are the duplicate, right? So if there are, like, say, there's two subtrees that are the same, right? They will return any of the two nodes, right? In case says any of the ones. So you just return one of the nodes, right? I'm saying, or the parent node, the root node of the subtree, right, as the answer, right? So return, and they're also gave us some good things, right? They're telling us exactly what they mean by duplicate subtrees, right? I'm saying, so if each subtree has the same structure and the same node values as another um subtree, then those two subtrees are duplicates. I'm saying that's how we define that. So I think once we go through the example, I think you'll probably get a more deeper understanding of what they're asking us to do, guys, right? So for this example, right, we could easily eyeball it and see that those two things are exactly the same, right? I'm saying because just by looking at the structure, the way they are organized, right? And also this one, right? This one definitely screams that they are duplicates, right? They are the same thing, right? You have the same structure and the same node values, guys, right? That's a very key thing for you to understand. I keep saying that, right? So also do not forget about those fours, right? I'm saying, right? Those things are duplicates, guys, because they are leaf nodes. They don't have any, I'm saying, children, right? And they're leaf nodes, yeah, and they have the same value. So the structure are the same. And also, I'm saying the values are the same, right? I'm saying, so let's say this was, I'm saying, this was like a two, right? Then those two would never be duplicates, right? I'm saying, just like let's say the values were switched, right? So let's say we had a four here and we had a two here, right? Those two fours would have been duplicates, right? But this two and this two, right? I'm saying those things, right, would not have been duplicates, guys, right? Because even though the structure is the same, but the node values are not the same, right? Because as the root node, this one's two, right? It would have been four in the case that I'm presenting, right? Then it automatically would not be the same, right? Because the values were not aligned correctly. It needs to be the same values, right? And the same way that they're organized, right? The same structure, I'm saying. So this example, right, is another good one, right? So you see, get this one and you get this other one, right? They're both leaf nodes, right? And they have the same value, right? Which means they have the same structure and they have the same value, right? Which pretty much tells us, yo, this is a duplicate, right? So you end up returning one as the answer, guys, right? And this one is a pretty the same example as the first one, it seems, right? So we see this two and this three, right? Two is the root node of this subtree, and the three is the child, right? On the left side, left child of two, right? And this is the exact same way, got the same structure. And on the right side of this two, right? I'm saying it's the same structure. Three is on the left side. And just like that, guys, we can conclude those two are the exact same because they're the same structure and the same node values, guys, right? Which makes it align perfectly, guys, right? So then we know the same case that we've talked about, three and the three. Three is definitely one of those examples, guys, right? Yeah, so it looks pretty good so far, guys, right? So how can we solve this, guys, right? Because we know we're gonna need a couple of things, guys, right? So let's go to our drawing board, guys. We just copy and paste it in so we can kind of talk about it, guys. Talk about some brainstorming, guys, right? So how can we solve this, guys? So we know that we need to know the structure of all the subtrees, right? I'm saying, I think that's kind of a requirement, right? So we're gonna need to kind of know the structure, and then in a way be able to correlate them between. I'm saying we can compare subtrees with each other, right? So by comparing the subtrees by each other, right, we can easily well, we should be able to easily compare the different subtrees with each other, right? And by checking them with each other, because they are cool, they have the same structure and they have the same value, we can say, cool, then you're a duplicate. So let me add you to my output result, right? So Yeah, we need an easy way to do that, right? So what's the easy way to do that, guys, right? So, and how can we do that, right? So, what I'm thinking about, right? I'm saying something that's kind of intuitive, right? We need to know the structure, right? Now, pretty much we could try serializing, right? No, by serializing the subtrees, right? We could pretty much use I'm saying we serialize that. I did a problem on that, guys, which was talked about serialization and deserialization of a binary tree. So if you guys haven't seen that problem, I highly recommend you guys go check that out. Pretty much I would do a lot of detail how we went about serializing and deserializing, guys, right? So it's a very good problem, right? So we serialize, right, the subtrees, what I'm saying, and then we could kind of use another data structure that gets pretty much kind of could hold the val that could hold the serializations of all of the subtrees that we're serializing, right? And then we could refer to that data structure, and I'm saying we already know when we're trying to duplicate, right? We normally use a set or a hash map, right? You know what I'm saying? Um, we use those data structures because we got this O1 lookup, right? We could either check, yo, does it have this thing already exists in the set collection of items, right? Does it already exist? If it does already exist, then you say, oh, cool, this is a duplicate, right? So we could use, so we know that we're gonna have to serialize, right? Serialize, okay? Serialize so that we can easily know, I'm saying, the structure of subtrees, right? So this is what the serialization is going to do, right? So if two subtrees end up having the same serialization, guys, we can conclude that those two subtrees are identical or pretty much duplicate, right? Because they already have the same serialization, right? And yeah, which means that they have the same structure and the values are the same, guys, right? So it's a perfect match. This is how we can correlate between the different subtrees, right? And check if the two of them are duplicates or not, right? Or more, two or three or duplicates, right? So yeah, so we're gonna be using a hash map, right? A hash map, why? To keep track of the frequency, right? We could easily use a set, right? A set, I don't think would have been good because uh, let's say there's three subtrees that have the same serialization, right? Since they have the same serialization, once we encounter it the third time, right? We would, you know what I'm saying, the third time we would add a duplicate result and output result, right? We don't want that actually. We actually want, you know, the first occurrence of that duplicate, right? That's the only thing that we're about. There might be millions of other duplicates, right? But we're not worried about that. We only want that first occurrence. We add it into output result, and any subsequent ones that we end up finding, right? Do not matter. We don't care about that since we were already accounted for in our output result, guys. So pretty much, this is what we're gonna have. So pretty much we add the serialization into the map, right? So the first time we see it, right, we add it to it. So the count will be one, right? And then once we see the same serialization again, right, we increment the counter to two, and then this is when we see this of serialization equals to two, right? I mean, there's two subtrees that have that serialization right at that time. Then we automatically add it to the output result, right? So let's go through a quick run, and yeah, and I think everything's gonna make sense to us, guys. So those are what we're gonna need to serialize and do. I'm saying serialize pretty much the map is gonna help us in keeping track of the frequency of this serialization, right? So we can easily check, we see I've been see this subtree. I'm saying as the serialization the frequency is equal to two, then we account for the guys, right? So yeah, so it's gonna be straightforward. So pretty much we're gonna do a post order traversal, right? This is what's gonna be needed to do the serialization, right? So we need the serialization of our left side and the serialization of our right side, right? Before we can serialize ourselves, right? And then we start up doing that, right? So pretty much, yeah, so we do post order, guys. So we visit our left, right, and then we process ourselves, right? So pretty much we go all the way down, right? Go to four. Four is gonna go to X, right? You know what I'm saying X, X, right? Right? And then those are, so pretty much the known nodes, right? We're gonna pretty much in the serialization, right? We're gonna add an X, right? So yeah. So now four is gonna serialize since four got the answer from the left side, it got its answer from the right side. Now it's gonna serialize itself so that it could send it to its parent. Because the parent called upon four, right, to give me an answer. I'm waiting on you, right? So pretty much, yeah. And this returns to the caller, right? So pretty much it looks like that, right? So that's kind of the how we're gonna serialize it, right? So pretty much we got delimiters, right, to separate the different values, right? So pretty much it's gonna be the node, the left side, and the right side, right? You know what I'm saying? So now before it sends it back to the caller, right, it's gonna add itself to the map, right? Because we're keeping track of all of the, I'm saying. So now the count is go to one, right? I'm saying because we didn't have that occurrence yet, right? So and then two is gonna call upon the right side, right? And there's gonna be X, right? So now two is gonna have to serialize itself, right? So it's gonna be two, whatever it got from the left side, which is I'm saying two X, no two, and then what it got from the left side, which is a 4XX, right? 4, comma, X, X, right? And then now what it got from the right side, guys, right? And which is X right there, right? So this is how we're gonna serialize it. It's gonna be root, that val, right? The value of the root that you own, right? Plus whatever you get from the left, plus no, obviously the delimiter, right? The delimiter is what I'm saying. And then we get from the left, the delimiter again, and then plus our right side, guys, right? And after we do that, we send it back to a caller, right? So this is what I'm doing right there. So this is the serialization of that subtree, right? You know what I'm saying? So the count will be one, right? You know what I'm saying? And then we go, and then one is gonna go boom, 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 and four is gonna serialize itself as well, right? Right, X, X, right? So now it's gonna send back, right? So before it does that, right, it's gonna add itself to the map, right? So this serialization is obviously gonna be 4XX, right? Which is the same serialization as this 4, right? So that's how we add it to the map, we increment the count to 2, right? And once we see that the count is go to 2, guys, we're gonna add that result, right? You know what I'm saying? So whenever we encounter a serialization that has a frequency of 2, right, we know that this is a duplicate because there's another subtree that we encountered before that had the same serialization as you did, right? Which pretty much tells us that that other subtree has the same structure as you do in the same values, right? So you see how we can easily do that. This is why the serialization is a very, very important part, able to us to really easily see the structure of our tree, guys, right? Right. So we output results, right? Pretty much gonna hold four, right? I'm saying, all right. We give it the four, and then now, and then two is gonna pretty much call on the right side, and then we know it's the same way that this was serialized, right? So now it becomes two, right? Because I told you guys we're doing root dev val, what I'm saying, plus the left side, which is 4xx, right? Which is 4xx right there. And then this extra x, right, for this right side, guys, right? So the count now, since we encountered a second time, we've seen this exact serialization, right? We compared to two, then we said, cool, this must be a duplicate, right? The same logic as the other one, guys, right? So we return a pointer to two, what I'm saying, two as the root node of that subtree, right? And just like that, guys, this is our answer, right? So we would obviously go to four, and the four is going to be the same serialization as those two fours, right? You know what I'm saying? It will have the same serialization, but we in the count will be incremented three, right? But it wouldn't matter. I'm saying since we only worry about the first occurrence of that duplicate, right? This is exactly what I'm saying. So it's three. We don't need to add it again to our output result, right? We don't need that because we already have that in here, guys, right? So hopefully you guys are able to get it and it kind of makes sense to you guys. So let's quickly go ahead with the implementation, guys, right? So yeah, it should be relatively straightforward after that, right? So let's just go ahead, guys. So what we're gonna need, guys, we're gonna need a output result, right? Like we promised. So res menu array list. Okay. All right. So we add our output result, and then we're gonna at the end return that result, right? And then we're gonna have a helper function, guys, which is we're gonna pass in our root, right? And also gonna pass in our output result. What I'm saying is gonna help us in populating that, right? And yeah, so what else we're gonna need? Yeah, we're also going to need, like I told you guys, right, a map of our serialization, right? You know what I'm saying? That maps the serialization to its frequency, right? You know what I'm saying? And the serialization helps us for the structure, right? So you can easily see, all right, cool. There's two subtree that have the exact same serialization, then those are dupes, right? This is what makes this important, guys. Right? So it's a very, very good problem. Yeah. Okay, so what we're gonna do, we gotta get some space for us to work. So helper, right? The arguments are will be, I'm saying, tree node roots, right? We're also going to have a list of tree node, right? Because that's what we need to return, guys, right? So we have our base case. If the root is null, we're simply going to return, guys, right? X, right? To signify it's a null node, guys, right? And after we do that, guys, what we're gonna do, we're gonna pretty much, go to my left side and get me my serialization so I can serialize myself, guys, right? This is what I'm doing right there, right? Do that right, and you're passing the output result. And then what's next for us, guys? It's that after we do that, guys, right? Serialize subtree. So now I see the where fun begins, where we serialize ourselves, right, before we send it back to the caller, right? For my parent, right? So we have to add the alert, right? The left and separate as well, right? All right, okay. So after we do that, we add an entry for it in the map, right? Because the map is gonna help us in keeping track of the different serializations, right? Okay. And we do the map that get or default that or zero, right? There's not an entry yet, +1, right? Cool. So after we do that, we're going to pretty much, this is the word the magic is, guy. If the map that I get, right? So get that exact same serialization, right? So get the how many times as this serialization happened before, right? I'm saying that exact same serialization, right? Which means pretty much tells us just the structure is the same and also the values are the exact same order that it is, right? If that's the case, guys, right? If the count is 2, right, which is the first occurrence of that duplicate, right? We add it to our output, right? I'm saying no, we don't add the serialization. We add the actual root node that we're on right now, right? Okay. And we return, guys, right, the serialization subtree to our parent, right? Because they need that answer so they could serialize themselves, right? So we can't be, we gotta remember them, right? So let's press run code, guys. See if we passed any test case, right? So looks good so far. Let's press submit, guys. See if we pass all the test cases. Awesome, guys. We're able to pass all the test cases, guys. So if you guys found value, make sure to give me a like. If you guys are new here, make sure to subscribe because I'll be doing a lot of other videos just like this one. So I want to thank you guys for watching, and I'll see you guys in the next one.